So CGPA can't be in real number.
Ma'am, it can be categorical also, right? Like along with continuous, it can be categorical because it categories between 1 to 10.
Okay, I'm not saying the category between 1 to 10. So one student asked me the question such as CGPA is the category between 1 to 10. Okay, fine. You can't have this 8.5 like that.
So it is in a category, right? Like how is it
So
not being into categorical
so
data?
how many categories are there? Can you count here? I mean, how many categories will be there? Fixed number of 2 or more categories. So how many will be there? For example, CGPA 1.1 can be there, right? 1.11 or 1.12, 1.3, 1.34, 1.5. So is there any fixed number of categories?
Okay, ma'am, I got that.
Got it right? Yeah, that's what.
But it's not going beyond 10, no, ma'am. It's between.
Yeah, 2 measurable points are there. If you could count, then it is
in that way, like we can do it in between 1 to 2, then 2 to 3, 3 to 4, 4 to 5. We can have 10 categories this way, or maybe like 1 to 2, 2 to 4 in that way again.
Yeah, 2 to 4. So it's a numerical value, right? It's actually numerical value. Categorical mostly will be non-numerical, and that too fixed number of categories will be there. If you could say grade, how many grades will be there?
A, B, C, D, E, F. Like it again depends, ma'am.
Yeah, you can count it, right?
Ma'am, but it depends, right? Someone can go with A, B, C. Someone can go with O, A plus A, B, B plus C plus C.
Yeah, we can
so how
have.
it is defined. But the number of categories, how it is defined, that how what number of categories?
No, I'm not saying number of categories is fixed, but we can list out the values of category, right?
Ma'am, so here also, like we can list out the categories from 1 to 2 and then 2 to 3.
No.
Also
What I said, CGPA. So what will be the CGPA? General CGPA. So I don't know about CGPA. Fine, we have the percentages. We don't have CGPA. So you have clear idea about CGPA, right? So how will the CGPA value will be there? Can you say the domain of CGPA?
It's up to 10. We can't have CGPA above 10.
Okay, fine. So 1 to 10. I mean, I want to know the values of CGPA, attribute values.
It depends like how it goes on. Like one can get 9.2, 9.3, 9.4. Again, one can get 8.14, 8.26. Like it depends how the value people are getting.
I think when it's an interval involved, I think it's simply continuous.
Interval continuous data means it's not countable. That is continuous. So here what I would like to say is CGPA itself is a numerical data and we can't treat it as a categorical.
And in that case, we can make CGPA and rankings also, ma'am. The one who gets higher CGPA will get rank 1. Like that, it can also be an ordinal way.
Yeah, that's you are processing CGPA and later you are deciding about the ranks. Okay, rank 1, 2. Ranks can't be in decimal point, right? 1.1.
Ranks are discrete, not the CGPA.
Which one? Yeah, ranks or discrete. So ranks can be, if you consider ranks as numerical data, so 1 to 10, then they are discrete. It can't be continuous. But CGPA is not a discrete itself. It's a continuous. That's what. CGPA is not a discrete. So what's your question? Your question is CGPA will be categorical, right? Your doubt is CGPA can be categorical. Is that?
Yes.
Okay, so how many categories can you list it? 1, 1.1, 1.2, 1.3, 1.4, like that? To till 10. Is it relevant or saying measurable values between 1 to 10 is continuous? So whether it is suitable to continuous data or categorical data? Think in that way. If we could say that a CGPA is only either 1, 2, 3, 5, so on up to 10, we can't have this real values, then we can say it is a categorical. but we have an interval data, right? It's an interval data. We can have any number of values. It's not, it's not an integer, but it's a real number. So how can you categorize it? It's not easy, right? I thought that CGPA will be a float value, so it will be continuous. That's my point of view. Because CGPA is some, 8.5 will be there, 8.3 will be there, like that. It varies from universities, right? Yeah. In general, CGPA will be continuous. That's it. Any other question? Okay, fine. What is the next one? Yeah, third one, okay. There is no order, so we'll treat it as nominal. And mean value can be calculated for nominal data. So no, it's not possible because categories will be there. So it's false. And fifth one, data mining refers to extraction of knowledge from large amounts of data. Yes. Discovering hidden patterns from already existing data. Yes. So both the answers are correct. The answer is both the above. If the question is given in such a way that CGPA values 1, 2, so on up to 10, no floating points are allowed, then we can treat it as a discrete data or even categorical data. Okay? Yeah. Let me share the screen. That's good that you're discussing the answers. Yeah, that's what I expect. I hope the screen is visible. Yes. So your next topic is why data mining. So we are drowning in data but starving for knowledge. Means we have more data and we want to extract the knowledge from that huge amount of data. All the data is not required. So only the knowledge extracted from the data is useful. So that is the main reason for data mining. So huge growth of data is there from terabytes to petabytes and now even to yottabytes. Okay, so where all these data coming from? If you consider the social media platforms, Facebook, Instagram, Twitter. So yeah, every second some millions of users will be sharing their interests, sharing their pics, videos in all these social media platforms. So all these are the data generated, right? Next, e-commerce. So e-commerce will be purchasing online in online platforming sites such as Amazon, eBay, Flipkart, Snapdeal. So all these are the data generated. And government sites, so online records, other links, bank transactions, and we even have news information, blogs, personal blogs will be there, official blogs will be there. So all these constitute the data. Okay. Yeah, to have the idea on different data, I have extracted this table from Wikipedia. You can find here. So yeah, kilobytes of data, megabytes, we know. So 1000 bytes is equal to kilobytes, and next, 1 megabyte is equal to 1000 kilobytes, gigabytes, next terabytes, petabytes, exabytes, zettabytes, yottabytes. So like these. So these are different units of measuring the data. Okay. So what is the data mining? So it refers to extracting or mining the knowledge from large amounts of data. We have the large amounts of data and we need to use certain tools for mining the data, mining the data to extract the knowledge. Yeah. Yes, data mining is about discovering the hidden patterns. Previously, we don't know the patterns, they are the unknown patterns. We are finding out from already available data. So you may get a doubt, what is a pattern? Pattern means the result of applying any data mining technique on the data. So what is the result? We treat that result as a pattern. The result of applying the data mining technique on the data is called a pattern. So finding out that hidden results, hidden patterns. Okay. So that is a data mining. So this extraction of knowledge is used for making the effective decisions. So which is based to the decision making systems. Okay. Yeah. Yeah. You can say this data mining as, it is a process of using a program for finding the patterns or relationships in the data. Okay, you're applying an algorithm, a technique, an algorithmic technique. It's nothing but a program for finding out the patterns in the data. Here I have given you two examples. Yes, you're looking for the combination of symptoms that are indicators of a given disease. So we have the disease a database, and then you're finding out which symptoms leads to these this disease, and looking for the products that customer tend to purchase together. So we are given a transactional data and we are looking for the common products which are frequently purchased by the customers. So what are all the items or products frequently purchased by the customers? So this kind of patterns. So these are few examples. And you may have a query in your mind. So we have a database management systems. Why we need this data mining? So database management system is simply searching the data from the existing data using some queries. You're simply querying the data. That is in case of database management system. But in case of data mining, it's not simply searching or querying the data. So you're finding out the unknown patterns from the database. Earlier, you don't know that kind of patterns exist. So you're applying some techniques on the existing data and then you're finding out the interesting patterns which are previously not known. And also in case of data mining, we used to perform some data pre-processing tasks in order to get the effective results. This kind of data pre-processing is generally not done on database management systems. Okay, so data pre-processing refers to we have many steps in data pre-processing. The name itself says that before actual processing, will do some pre-processing. So processing before actual processing, that is a pre-processing. So I'll give you an example. Data cleaning. We may be having a huge data where the data may be missing. There exists some missing data, so what we'll do in that case, we can't do the data mining directly. We'll perform some pre-processing technique to handle that missing data. Okay. Yeah. Yeah. Finding null values. Yes. Somebody asked the question. So there will be some null values. So we need to handle all that missing values as well as null values. So that is one kind of data cleaning technique. And also, we may be having data with some thousands of attributes, but all the attributes may not be required for mining specific kind of data. So what we'll do in that case, we'll select the appropriate data. So for this kind of analysis or mining, we need only these group of attributes. So we'll select some part of the data. That is one kind of pre-processing, data selection. And there is a chance to transform the data to a suitable form for mining to get the effective result. So data transformation. And also we can reduce the data by applying some reduction techniques, data reduction. So all these are data pre-processing. Okay. Wait, I can't see this chart questions. It's hidden. Yeah, okay, fine. So what can be data mining be used for? You can use it in medical fields, health data mining. It finds the occurrence or cause of certain critical diseases. And also we can use the data mining in e-commerce for recommending the products, in case of web page analysis. And in case of stock market also, we can apply some prediction algorithms. So all these are areas where you can use the data mining. Yeah, motivation to study data mining. As I said previously, we are drowning in data but starving for knowledge. That is one main reason. So as we have a large amount of, massive data, we need to manage that data. We need to process, analyze, predict, and find some insights from that data. Okay. Yeah. If you consider this online retailing, so this online retailer will be interested to know the customers market basket, and he can better advertise, display his items for cross selling and upselling, and provide some discount on the items, and target the customers. So all these come under your retailing. And also a retail clothing chain, for example, if you consider this category of clothing example, so how to give discounts on certain items such as winter codes in certain region present. Okay. And also bank, in case of banking, a bank wants to know which customers to target for credit cards and loans, so finding out the target customers. And insurance company, so they may use this data mining for finding out the fraud patterns in healthcare. There may be some fraud patterns in healthcare. So, in order to get the insurance, so customers may be applying, without following certain procedures. So, there will be certain procedure for insurance company, right? So, all their terms and conditions must be satisfied. So, there also we can apply data mining in order to find the fraud patterns. Yeah, so these are few examples. Why we need to study this data mining and how it works. Yeah, we have the data. We need to select the target data. As I said, multiple features for the data. We need to uh, find the target data. We need to select a specific a data, and then pre-processing can be done so that we can apply the data mining technique and then get the efficient results. Without pre-processing, we can't be getting the efficient results. Okay, so we need to pre-process the data, and we need to transform the data into a suitable form for applying the data mining technique. So for example, there exists some data mining tasks where we can apply the technique on a specific kind of data. Only a specific kind of data we can apply that technique. So we need to transform our data into that type. Maybe we are having, for example, age. If you consider age of the customer, it will be in numerical form. So we can convert that to categorical data. So yeah, you already previously asked this type of question, CGPA, right? So you can get some idea on this now. So age is numerical. So what we'll say, we won't be saying age as categorical, right? Will you say age as categorical? Generally, what we say, age is numerical, but I can convert it to categorical. for my application. For example, I will define 3 categories. So middle-aged, young, and senior citizens. I'll define the categories, and then based on the values of that age, from this to this age, from, for example, from 15 to 25 young, from 25 to 45 middle age, from 45 to like that senior, like that. So previously someone's while discussing this quiz bit, what is that, CGPA, someone said from this to this we can categorize, and from this CGPA to this CGPA we can give another category. Someone said, right? Who is that? One boy and discussed this point. I don't remember the name. Yeah, we can assign the categories based on that range. So initially ages, it's not categorical initially. What is the type of age? It's numerical, but I'm transforming it to categorical for better analysis. Okay, so this is an example for data transformation that I want to discuss here. So yeah, data transformation can be applied, and then patterns can be generated by applying the data mining technique, out of which will get the knowledge. The final result is the knowledge. Okay, so this is an iterative process actually. So we have the arrow marks. So this is an iterative process. So once the suitable patterns are not acquired, then we'll start the process again. Okay.
Do we use any tools, ma'am?
Yes, we use the tools. So they are called as data mining functionalities. That is your next topic. So we have different data mining functionalities, and many tools exist for performing each functionality. Okay. Yeah.
So what is difference between data mining and data analysis? Is it same or?
Data mining and data analysis.
Yeah.
Yeah. So data analysis means it can't be always data mining is always extracting the unknown data, whereas data analysis refers to more into a statistical aspect. Okay, so finding out the statistical aspect of the data and more about the visualization of the data. Okay, you're visualizing the data in a simple form. So that is a data analysis. So data mining is actually knowing about the unknown things. Previously, you don't know that kind of patterns exist. Now we are finding out that unknown patterns. That is mining. Okay. So what do you mean by gold mining? Previously, we are extracting gold.
Extracting the hidden gold.
Hello, I can't hear.
Extracting the hidden gold.
Yes, that's gold mining, right? Hidden gold is extracted from that rocks and all those things. Okay, so like that, data mining works. Data analysis means actually it's more about what exists in the data. You're representing the data, and maybe you're representing the data in a simple form, or more into the statistical aspect, such as what we can say, finding out some means, standard deviation. So statistical techniques are applied in analyzing the data. Okay, so that is data analysis. The existing data is analyzed so that it will be in more understandable way. Okay. Yeah, finding patterns in the data is data mining. Yeah, Pawan, that's correct. Finding patterns in the data is data mining. Yeah. Yeah, we have several terms and several techniques related to data mining. That is your next topic, data mining related technologies. We have a machine learning. So somebody will be still confused with what is data mining and what is machine learning, how it varies from data science. We have statistics. So there are different techniques related to data mining. Artificial intelligence is there, machine learning is there, data science is there. So how all these are related, we'll see that topic in the later classes. Okay. So actually, we have a term called data analytics. Okay, so in case of this data analytics, uh, as you asked the question, what's the difference between data analysis and this data mining? Wait a second. Yeah. So data analytics means we have, you're predicting the data, you're describing the data. Descriptive analytics exists, predictive analytics exists, and prescriptive analytics exists. So, what happened to the data? That is, you're describing the data. That is descriptive analytics. What could happen in the future? Analyzing that kind of analyzing and answering that kind of questions is predictive analytics. Okay, so what to do for solving that? So you are predicting the future. So what could be the solution for that? You are predicting this kind of what could we say? Yeah, you are finding out the patterns that in case of in case of crime detection, these kind of patterns exist. So these kind of crimes will happen. You are predicting. That is a predictive analytics. So what is the solution for that? That is, you are prescribing some. Yeah. Solution? Yeah. Prescribing some solutions for that. So that is prescriptive analysis. So analysis is a part of analytics actually. So there is a difference between analysis as well as analytics also. Okay, prescriptive analytics are there. So data analytics is more, it's a superset for data mining. Okay. Data analytics is a broader area than the data mining. I hope you understood. Analytics deals with what happened, why it happened, what could happen, how to deal that situation. Okay. Who asked this question? It's good actually. Who asked this question? Okay. I hope you understood a difference between data mining and analysis.
Yes, ma'am.
Yeah. So analysis is a part of data analytics, which is a broader area than the data mining. Analytics, as I said, it will deal with what happened, why it happened, what could happen, how to deal with that situation. Okay, so this is a complete process. Analytics is a process. Okay, yeah, analysis is one part in that analytics process, and data mining is, it's finding out the hidden patterns from the data. Your mostly data mining deals with description and prediction. Description and prediction, but analytics and analysis, more than this a description and a prediction. They'll even prescription analytics is there. Okay, it will even provide the solutions for that. Okay, so data mining is a part of the data analytics. You can say like that. Yeah. Yes, the result of finding out the insight, Pawan, as you said, the result of finding out the insights is it will be useful for the stakeholders for improving their business. In business decision making process, it will be useful. Yeah, that's correct. Yes, data mining methods. We have any data mining method will fall into two tasks. One is a descriptive task and another one is predictive task. So descriptive task means it finds out the patterns which describe the data. That is a descriptive. For example, if you have the Facebook data or Instagram data, the number of followers, likes, posts. So these can be used to find out the average number of replies for each post, the number of page views, and the average response time. Okay, so all these are descriptive tasks. and even summarizing the past events and representing them is a descriptive task. Okay, you're finding out the human interpretable patterns which describe the data. So describing the characteristics of the data. So that comes under the descriptive task. And the next one is predictive task. Predictive task is we are predicting the unknown or future values of the outcome. For example, we can predict the customer preferences and recommending products to customers based on the past purchases and search history. So we have the data here. We have the purchase history of the data, search history of the data. Based on that, we could generate the patterns which will show the customer preferences and product recommendations. Okay, and also predicting the likelihood that customers will purchase another product or leave the store and move on to the another store. This is a customer churn prediction. Customer churn prediction means the customer may move on to the another store. So based on their based on the existing store items. Okay, so yeah, knowing the customer data, they could even predict whether the customers will continue purchasing in their store or they may leave to the other store. So this kind of prediction comes under the predictive task. So the common data mining tasks I have included here, there are four: association rule mining, clustering, classification, regression. So these are the common tasks. Yeah. So descriptive and predictive. If you consider any task, it may fall into either of these two categories, either descriptive or predictive. Yeah, let me discuss. So this example I have given you to know the difference between descriptive task and predictive task. This is not related to data mining in general. What's the difference between descriptive task and predictive task? So for example, you have the data set x, y, two columns. So if x value is 2, y value is 4, if x is 3, y is 6, if x is 4, y is 8. So descriptive task here refers to finding out the values such as sum of x, sum of y, mean of x, mean of y. So finding out this kind of results, you're describing the data set. You're describing the data set. Okay. So this is a descriptive task. And coming to the predictive task, from this available data, you have to develop a model in such a way that if x is known and y is unknown, you should predict y. And similarly, if y is known and x is not known, you should predict x. So that is, if a new value for x is given such as 5, what could be the value of 5? If x is 5, what could be the value of 5? So you have to develop a model from the given data set. So this kind of prediction or this kind of building the model is called the predictive task. Okay. Yeah. See this. This is the association rule mining, which is an important data mining task. So in this image, you can see market basket analysis. Yeah, market basket analysis. It is termed as market basket analysis. You can see the shopping basket. So it consists of certain items. You can see all these items which are marked here. And here what we are generating is, we found a rule such as 98% of people who purchased items A and B also purchased item C. For example, 98% of the customers who bought milk bread also bought butter. Okay, so we have generated this rule. How this rule is generated? From the existing data. So based on the purchase history of the customers, we have generated this rule. I mean, most of the customers, based on the frequency of the purchase, most of the customers who brought, most means here a numerical value is also given, 98% of the customers who purchased milk and bread also brought butter. So these are frequently purchased. These are associated items. So this kind of rule generation is called association rule mining. Okay. So previously we don't know this information. This pattern is not known previously. Now from this data, we applied the mining association rule mining technique and came up with a rule such that that rule is 98% of the people who bought the item C and B also bought the item C. So these are useful rules. For example, if you consider the Amazon, so these Amazon, so it is skilled at using their data to uncover the insights into what types of products customers may want based on what they have already bought. So based on the previous purchase history, they could find out the insights such that what types of products the customers are willing to purchase. For example, Amazon may see that someone who purchased kitchen knives will likely be interested in cutting boards, cutting gadgets for fruits and vegetables, and specialized knife cleaners like that. Okay. So whenever we log into Amazon, so they'll be suggesting some products, right? So the customers who have purchased this item also purchased this. You have last seen these items and some of the related items. So we'll be getting some suggestions. Okay, this is possible only when some insights are known from the previous purchase. Okay. Yeah. And clustering. Some question. Yeah, it's used in recommendation system. In case of recommendation systems, this kind of association mining technique is used. Yeah. Yes, clustering. Clustering generally it refers to grouping of data. So how we group the data? Based on the similarity. Based on the similarity, we'll be grouping the data. Okay. So identifying the groups or classes in a data which are similar to each other is said to be clustering. So here you can see this image. So there are several entities. Entity means data. Several entities are there. So based on their features, we can group them. Right? See, all birds will fall into one group and all animals will fall into another group. So based on their features. So birds can fly, animals cannot. So it's one of the feature which helps in grouping these data. Okay. Yeah. For example, you don't know about vegetables and fruits. Okay, for the first time, you don't know, right? When you are a kid, you don't know. So you are given a basket of vegetables and fruits, and you are asked to group them. What we'll do? We'll see at the features only. We'll see at the features, and even so all based on the features we can group them. So all vegetables at one side, all fruits at one side, like that, right? We'll group. We don't need any prior knowledge. We can group based on the features. Okay, so like that. So this clustering is useful for business people like real estate, where the agents might be looking for the home sellers in a specific region with certain education levels to help them locate their perfect potential customers. So this is customer segmentation. Okay, so customer segmentation can be done in case of this real estate business. So your even retailing business and e-commerce. So they'll try to find the target customers. Target customers can be found only if clustering can be applied. Okay, we are grouping the customers based on their features. Features means not physical features. Their features of the data set, customer data set, based on their attributes. Okay, you can group the customers based on their purchase behavior. So whether they are frequently purchasing or regular customers or irregular or rarely, like that. Okay. Next, classification. Yeah. So this is also one of the data mining technique. Okay. So many of you will be confused with classification and clustering. So I would like to give an example. Yeah, classification is, you already know what is a cat and what is a dog. You already know cat looks in this way, dog looks in this way. And you were asked to assign a class label for that animal. As you know all the features, you will assign that animal to either cat or dog. So, see here, it is the process of identifying to which category or class this particular observation belong to. You are already given certain labels, certain categories are given. You have to identify to which category this particular observation belongs to, whether it is a cat or a dog. Okay, you're classifying. Same example that I have discussed in case of clustering. So, yeah. So, what is the example that I've discussed? A kid was given all the items with fruits and vegetables like that, and he is asked to group them, right? So that is based on the features, he can group them, all the similar items in one group like that. Okay. In case of classification, the same kid is given an apple, okay, and then I asked him to identify it as fruit or vegetable. I've given an apple and then I have asked him to identify whether it is fruit or vegetable. Okay, so unless he know how the fruit looks and how the vegetable looks, he can't classify, right? He can't classify. So prior knowledge is required for classification, but prior knowledge is not required for clustering. So that's the simple difference. That's why we call this classification as supervised learning, as we need prior knowledge. We call it as supervised learning. This is in terms of machine learning concepts. In terms of machine learning concepts, classification is said to be the supervised learning. And in the case of clustering, as we don't require the prior knowledge, we call it as unsupervised learning. Learning by itself. Learning by itself. So based on the features present in that data set itself, will find out the groups. Learning by itself. That is unsupervised learning, which is the clustering. But in case of classification, we need to have a knowledge on the labels. So already the labels must be there in the data set. Otherwise, you can't classify a new data, whether it belongs to label 1, label 2, like that. Okay, yeah. So here an example is given, a credit card company. So credit card company can use this classification technique for analyzing the data and determining whether or not a credit card offer should be given. Okay, so yeah, I mean, they may be having data such as credit is either good, fair, excellent, or bad. If this particular customer data label, then you given the, okay, you won't be given the credit card if his credit is bad. Yeah, so already the data is existing and we need to classify whether this new customer belongs to which group, bad credit, good credit, or excellent credit, like that. So do you have any doubt regarding classification and clustering? Well, in the next classes, we'll discuss more examples related to this. This is just an introduction. So this is a PPT that I want to discuss for the initial class.